Welcome to my channel Behind the Binary. In this lecture, let's discuss about PyTorch arrays. A torch tensor in Python refers to the core data structure used by PyTorch, a popular deep learning framework. A tensor is essentially a multi-dimensional array. Install required libraries, which are torch and numpy. After installing required libraries, import torch and numpy. Torch arrays are similar to numpy arrays, but with additional features optimized for deep learning tasks, including automatic differentiation for gradients and backpropagation, GPU acceleration via CUDA, dynamic computation graphs. Let's have a look how torch arrays works. Creating a temp array to variable x by arranging with numpy. This will arrange integer values starting from 1 to 10 in variable x. Tensor is a generalization of scalars, vectors, and matrices to more than 2 dimensions. Scalar is a single numerical value. Vector is an ordered list of numbers, essentially a one-dimensional array. Matrix is a 2D grid of numbers arranged in rows and columns. After arranging, let's take the array to torch array by using from numpy. Let's print the type of x1 and print x1 to see the output for tensor array. In PyTorch, from numpy is a function that creates a tensor from a numpy array. It provides an efficient way to convert numpy arrays into PyTorch tensors, and the tensor will share the same memory as the numpy array, meaning changes to one will affect the other. Array, a numpy array that you want to convert to a PyTorch tensor. Let's run this file and see the output for variable x1. It will become the type of torch, tensor. In PyTorch, a tensor is the core data structure. It's a multi-dimensional array, similar to a numpy array, but with additional capabilities such as running on GPUs, automatic gradient computation, and support for deep learning models. Represents an n-dimensional array. Can hold data like scalars, vectors, matrices, or higher dimensional arrays. Can be created with or without initializing values. You can now see in the output which is type of torch tensor, and the array which we arranged using numpy. Now creating array with numpy arrange float values of 12. Which is being assigned to variable x2. After arrange, I'm reshaping the array with two-dimensional array as 3 by 4. Storing reshaped array to variable x3. Similarly how we did for one-dimensional array, I'm trying to append this array to torch numpy with variable x4. Now printing the type of x4 and printing to see the values of x4, which is two-dimensional array. Let's run the Python file and see the output for this two-dimensional array, how it is storing to variable x4. Now in the output you can now see the tensor from numpy is storing this two-dimensional array, which is with float values. Similar to from_numpy function, we have two other functions which are tensor and as_tensor functions. Difference between from numpy tensor and as tensor functions are: from numpy function shares memory with the original numpy array. Tensor function always copies the data to no shared memory. As_tensor tries to share memory if it can, example with numpy. Am now trying to check the function torch.tensor with variable x and variable x3. Let's see the output. I will be similar to from_numpy function, but tensor function always copies the data to no shared memory. In the output window, you can now see how the output is showing for x1 and x4. I'm also trying to print the initial values. You can check those or remain unchanged because variables are separately created for all assignments. Then now let's try to check as_tensor function with torch library. Now I'm changing the assignment to the variable x1 to torch.as_tensor. Also to the variable x4, I'm changing the assignment of torch.tensor to torch.as_tensor. The output for as_tensor will also be remain same, but as_tensor tries to share memory if it can, example with numpy. Now let's see the basic arithmetic operations with torch tensor arrays. In TensorFlow, an operation, often shortened to op, is a node in a computational graph that performs a computation. These operations are the core building blocks of all computations in TensorFlow, whether it's matrix multiplication, addition, reshaping, activation functions, etc. Taking two variables named a and b, storing one-dimensional arrays to those variables to perform basic operations. Now this variable are having integer values with tensor array without numpy. AM performing couple of arithmetic operations like addition, multiplication, subtraction, division, etc. Tensor operations are fundamental building blocks in deep learning and data processing. We can also perform operations with multi-dimensional arrays. Tensor operations are extremely useful in image processing because they allow you to efficiently load, transform, analyze, and train models on images using a unified GPU-accelerated framework. In PyTorch, everything, images, models, gradients, is represented using torch, Tensor. Let's see the output, how it is working. In the output, you can now see the operation which I'm trying to make in Tensor, Py, which are working as expected. In the next lecture, let's explore machine learning concepts in detail. How this NumPy and Pandas and PyTorch are useful in deep learning and AI models.